Hello, this is Alice Jacoby. I'm here today to discuss with you the Space Shuttle Columbia disaster and to specifically look at some of the underlying organizational causes and issues of culture at NASA that led to this catastrophe. I wanted to first pull out a few key dates just to provide us some context as we examine this situation, and specifically to look at the history of Columbia in the context of the larger space shuttle program at NASA and also in relation to the International Space Station. Columbia was NASA's very first space shuttle to take flight, its first launch being all the way back in 1981. And a huge part and a huge goal of the space shuttle program overall was to help construct the International Space Station. President Reagan, in his 1984 inaugural address, formally challenged NASA to get this done within 10 years. Unfortunately, just a couple of years later, the Space Shuttle Challenger, as you're probably aware, tragically exploded upon launch, killing all on board. At that point, the Space Shuttle program was halted for a couple of years as they looked into that disaster and how to best move forward. The International Space Station continued to face significant delays, overages in budget, and it wasn't until 1998 that the first space shuttle mission to actually help construct the International Space Station took flight. In 2001, President George W. Bush appointed Sean O'Keefe as NASA administrator. O'Keefe came from a background in the Office of Budget and Management and was brought on board with a mandate from President Bush specifically to help keep the International Space Station on track in terms of budget and in terms of schedule. It's within this time frame and this context that brings us to the Columbia mission STS-107, which would tragically be the last mission of Columbia. This mission launched on January 16th in 2003 and carried 7 NASA astronauts. This mission STS-107 was uniquely research-focused, and the 7 astronauts on board spent day and night conducting a variety of scientific experiments. The mission went well, and on the 16th day, they were scheduled to return to Earth. Unfortunately and tragically, during their re-entry to Earth, the Columbia broke apart and killed all on board. The first sign that something was wrong on the ground was when Mission Control lost several signals that were unrelated but were on the same left side of the orbiter. They soon after lost communication with the crew. Attempts to reestablish communication were not successful, and ultimately they received word that witnesses on the ground had seen fiery streaming debris falling through the air over Texas, and it soon became clear that neither the orbiter nor the crew survived. So what caused this disaster? The technical cause of the disaster was determined to be damage to the left orbiter wing caused by a small and approximately briefcase-sized piece of foam that was dislodged from the external fuel tank during launch on the very first day. That piece of foam struck the orbiter wing, causing a large crack or a hole. The damage was such that upon re-entry into Earth's atmosphere, the fiery atmospheric gases and plasma were able to enter the wing, ultimately destroying the wing and then ultimately leading to the loss of the craft and of the crew. This was not the first foam strike, quite far from it. In fact, there had been incidences of foam breaking off during launch, stretching all the way back to the very first flight of Columbia in 1981, so from the very origin of the Space Shuttle program. In addition, there had been 6 previous instances where they had witnessed during launch foam breaking off from the external tank from the exact same place that occurred in the last and fatal mission of Columbia. This being said, even though foam strikes were fairly common, There was a group of NASA engineers involved with the STS-107 mission who, on the second day of flight, they grew quite concerned after viewing some footage of the launch. The footage was somewhat blurry and not quite clear, but what they saw in regards to the foam strike alarmed them, and so they wanted to look further into it. A group of 30 plus engineers came together to form the Debris Assessment Team, or the DAT, and a main priority of this team was to secure additional footage for analysis. And so it was possible to request through the Department of Defense, the US Department of Defense. They had access to high-resolution footage from their satellites that were orbiting Earth. And so the Debris Assessment Team wanted to gain access to some of that footage so they could look at it and hopefully get a better picture of what that potential damage was, and whether that would pose some sort of significant threat to the mission and to the astronauts on board. Unfortunately, their requests were all denied. Ultimately, the mission management team decided that the requests were not necessary, and they declined to request this additional footage from the Department of Defense, despite the fact the Department of Defense was prepared to provide it. So how does this happen? First of all, how was NASA unprepared for the potential danger of foam strikes in general, considering it had been an issue in so many missions before this? And secondly, why were these requests from this group of concerned engineers, multiple requests, repeatedly denied by upper management when this was a group of employees of NASA who had high levels of expertise and knowledge about the mission and were trying to raise an urgent safety concern, yet their requests were repeatedly shut down? So to answer these questions, we have to look at and examine the deeper culture of NASA at the time. And what becomes very clear initially in examining this case is that the mission management team for this mission had begun to adjust their behavior and adjust their strategy in response to external pressure. Of course, as you'll remember, as I mentioned, O'Keefe had come in and had set a very strict guideline, or a strict deadline, so to speak, for all of the components of the American components for the International Space Station to be delivered by February 2004. This would require 5 missions, 5 space shuttle launches within 1 year, which was quite ambitious for NASA. And so the management knew that any delay in this mission, that would snowball, causing delays for future missions and making it much harder to reach that intended goal. Of course, this was a very public goal. It was set by NASA's administrator. It was pressure from the White House and the administration, pressure from Congress, who controlled the funding. Obviously, NASA is a very publicly visible organization, and with a long history of delays and embarrassments around the International Space Station, there was a lot of pressure on management to really meet these deadlines. What exacerbated this problem as well was that some members of the mission management team, including Linda Ham, who headed up the MMT, was also in charge of the following mission. And so she was very well aware of the trouble that would face her personally down the line if this mission were to become delayed in any way. And so this leads into the idea that over time, these external pressures led to a sort of goal displacement. An idea brought forward by Merton that the rigidity of these formal rules and processes and external pressures can become so rigid that they lead to behaviors to appease them, and they lead to behaviors and strategies that can displace or take precedent over the original organizational goals, which of course the goal of NASA should be to safely deliver astronauts to complete the mission. And so slowly this eroded the culture of safety, and generally it became normalized to classify these foam strikes as a maintenance concern as opposed to a flight safety risk. Each time that one was assessed as such, it became easier to assess the next foam strike as a maintenance concern as well. So it led to a sort of path dependence where because something had not caused destruction in the past, it was viewed to not be causing destruction now or in the future. And obviously that is not a good substitute for, especially like an organization with NASA, when you're dealing with the incredible risk and human cost and expense of independent and rigorous safety checks. Another primary issue was the failure of communication structures. The engineers involved with the DAT did not have an avenue or an opportunity to directly voice their concerns to management. Their concerns were thus summarized, and they were thus watered down, and they were summarized by someone within management who shared the same sort of groupthink that the rest of the management team did. And so that person was in some ways incentivized to frame these concerns, to downplay them, and to frame them by focusing on the history of foam strikes as a maintenance concern as opposed to a risk. And then this managerial communication became a self-reinforcing loop. So those are some of the main factors at play. So some recommendations and key takeaways, both for NASA itself, but also more broadly applicable to the world of management and public management. This was an issue of culture. While we don't want to absolve the individuals involved of their responsibility in this disaster, it's very possible that you could have replaced each of the individuals with a totally different person and the exact same scenario would have played out based on the deeply ingrained culture of NASA and culture of management. So it's something to be very aware of. Additionally, drawing on that, the dangers of path dependence that we spoke to, organizations must strain as much as they can to maintain the integrity of internal assessments. In NASA's case specifically, the Columbia disaster made it clear that the need to maintain safety evaluations should not be based on prior outcomes but that they're being engaged independently and rigorously. It's impossible, of course, to eliminate these sort of external pressures, but as much as the organization can do so and continue to focus on their actual mission at hand. And then also, it's important, and this is a good lesson in that it's important for management within a public organization to value the expertise and the knowledge of non-management professionals. These engineers are a great example of a group that had a lot of expertise, that had a lot of on-the-ground knowledge, and yet they were not taken seriously, essentially. And so this is very important for a public manager to keep in mind. That this sort of strict top-down approach is not going to work in a public organization, and especially an organization like NASA, where people do have such specific technical knowledge. There has to be an opportunity, and this leads into my fourth point of formal and informal communication channels. There must be an opportunity for these sort of employees and these lower, so quote called low-level employees to bring their opinions to the top. And if necessary, for there to be an avenue for this sort of concern to bypass management in this sort of serious case. And so these are just a few of the key recommendations and takeaways that we can gain from this tragedy. It's really important, obviously, a disaster at this scope, to look as hard as we can and see what really causes at the core outside of the individual actions, and what sort of deeper lessons can we draw from this in order to improve an organization like NASA moving forward, to ensure that the safety of those who are risking their life for their country remains at the utmost. But also more broadly, how can we look at what happened at NASA and apply it to other organizations and to other missions as well? I hope that you have gained something from this talk, and I thank you for your time.